Okay, let's take a look at the section 1-9 notes. We'll be doing the homework in class, so all we're going to do tonight or today when you look at this video is we're going to do the notes in the packet, and then you'll be ready for the actual work when we get to class on Monday. So we're going to take a few minutes and review distance and midpoint. Remember the distance between 2 points. Talking about the distance between A and B, so we'll write A and B, is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, this gives me the square root of -3 squared plus -6 squared. So this gives me 9 plus 36, which would be the square root of 45. You can simplify that because 45 can be factored into 9 and 5, 9 being a perfect square, so that becomes 3 square root of 5. Okay, the next is finding the midpoint of a segment. Remember, this is the distance between, represented as a single number, so the distance between those 2 points. This is the middle of the line segment, so the middle of that line segment. And remember, this is just the average, so you're going to take the x coordinates, 5 minus 4, divide by 2, then the y coordinates, -7 plus 6, divide by 2. So we have the middle of this line is at 1/2, -1/2. The next one, remember, is a challenge to look at. This is where you are given an endpoint and the midpoint, and you are asked to find the other endpoint. So D is an endpoint. M is the midpoint. And we found the easiest way to do this is to just look at how this line changes from one endpoint to the midpoint, and then adding that on to find the other endpoint. So we have the endpoint we're looking for. Remember, we look for the difference in the x, so it changes from D to M by +8. So therefore, it changes from M to the other endpoint by +8, making this 13. Do the same thing for the y's. Look at how the y value changes from D to M. It changes by +6. Therefore, from M, the midpoint, to the other endpoint will change by 6 as well, making that ordered pair of that other endpoint 13, 14. Okay? This section now is about perimeter, circumference, and area. So it's important to go back over those definitions of perimeter. The perimeter of a polygon is the sum of the lengths of the sides, and it's represented in units. So if I have a polygon, that looks like this, and this is A, B, C, D, and E. The sum is A plus B plus C plus D plus E equals the perimeter. Okay. The next is the circumference. And the circumference of a circle is just essentially the perimeter of the circle. It is the distance around a circle. So if this is my circle, I'm looking for how far around. how many units it is to go all the way around that circle. The formula is the circumference is equal to 2 pi r, where r is the radius. Okay, so the circumference is 2 pi r, where r is the radius. Next is area. Area is the number of square units that fit inside a figure. So if I'm looking at a rectangle, I want to count how many square units would fit inside that rectangle, and that would be the area. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long and 5 units high. So I would have 50 units squared in that particular figure. I don't think the next part is in your note packet, but let's go over just a few of these little formulas. You've seen them before. If you have a square, it's just s squared, which is like a rectangle, which is base times height. You can use base times height with a square. It's the same thing. The other one that you need to write down and make sure that you have is the area of a circle. Area of a circle. Okay, and that is equal to pi r squared. So when you think about this, you're looking, area looks for square units, right? Area looks for square units, and here we have the radius squared. So hopefully that'll help you associate area with pi r squared. Then you can look at circumference as just 2 pi r. That's probably the most confused, so you want to make sure that you understand the squared, pi r squared, matches area, square units. Circumference is the distance around, and so there's only r there, not r squared. Okay, let's take a look at the next problem in your packet. And it says that your pool is 15 feet by 20 feet. So it's 15 feet long or wide, 20 long. Then it says there is a 3-foot wide deck that surrounds your pool. So that's this area all the way around, surrounding that pool. You want to build a fence around the deck, so your fence will be here. That's where your fence is going to be. So now, if you want to build that fence around, what you have to think about is how long is this once we have the deck. We know it's 15 here. We're going to add 3 feet here. We're going to add 3 feet here, which is going to give me a length of the side as 21. Then when we look at the length of the pool, we know that's 20, but we're adding again 3 feet here, and we're going to add 3 feet here. Okay? So that makes this total side 20 plus 3 plus 3, or 26. So when I look at the perimeter, that's going to be 21 plus 21 plus 26 plus 26. Some of you might also write that as 2 times 21 plus 2 times 26. Both are correct. So that gives you 42 plus 52, or 94 feet. And that would be the amount of fence that you need to surround this pool, including the walkway. Okay? Next question asks you to find the perimeter in the coordinate plane. And it says find the perimeter and area of the rectangle with the following coordinates. So I'm going to graph these. I have A at -2, 4. Remember, this is x, this is y. In an ordered pair, x comes first, y comes second. So let's graph these. -2, 1, 2, 3, 4. That's A. B is at 4, 1. 1, 2, 3, 4. 1. So there's B. C is at 3, -1. So here's C. D is at -3, 2. So there's D. And we're told it's a rectangle, so we know that the opposite sides are the same length, and therefore we'll only have to do the distance formula twice, because we know that AB is the same length as DC. We'll actually prove that later in the year, but for right now, we're just going to accept that as fact. So the length, AB, is equal to the square root of -2 minus 4 squared plus 4 minus 1 squared. So I get the square root of -6 squared plus 3 squared, which gives me the square root of 36 plus 9, which equals the square root of 45. Hopefully, you can simplify that because the factors of 45 are 9 and 5. 9's a perfect square. Square root of 9 is 3. So in simplest radical form, that's 3 root 5. 3 root 5. Some of these we'll also find decimal form for. So let's do that. Square root of 45 is approximately equal to 6.7. Okay, now let's find BC. We know that AD is equal to BC, so the length BC we find by taking the square root of the first x coordinate 4 minus the c coordinate and square that. Then we'll go on to the y, so 1 minus -1 squared. So I have the square root of 1 squared plus 1 minus 1 becomes positive, so that becomes 2 squared. This gives me the square root of 5. Okay, so now I'm asked to find both the perimeter. So remember, the perimeter, P, is equal to the length of AB plus BC plus DC plus AD. And I have values for all of those at this point. And I have them in radical form, so I could try that, and then we'll do decimal form. So AB is 3 square root of 5. BC is the square root of 5. DC is 3 square root of 5, and AD is the square root of 5. Add those together, and this becomes 8 square root of 5. In decimal form, I have 6.7 plus 2.2 plus 6.7 plus 2.2. Which gives me approximately equal to 17.8. Then the area, I'm going to take the base times the height. In radical form, that would be 3 root 5 times root 5, which becomes 3 square root of 25, which becomes 3 times 5, which is 15. And again, you could do that with the decimal approximation, 6.7 times 2.2. And your answer will be slightly different because we have rounded those answers, okay? Because we've rounded before we multiplied. We're going to get a slightly different answer. Now the next one's really important in how to think about some of these problems. And I think there are two. I might have to add the other one that's in your packet. This says, find the circumference of a circle that has an area of 64. So you have the area and you want the circumference. What I like to do is write down what I know. The circumference is equal to 2 pi r. The area is equal to pi r squared. So what I want to know is, what do they have in common? Well, they have the pi in common, but I know that that's 3.14, etc., etc. So that must not be the common element, but they have this r in common. So if I can find r, I think I can find that circumference. So we're going to substitute in what we have, this 64 pi, into the area formula. So this becomes 64 pi is equal to pi r squared. To simplify this, I'll divide both sides by pi and eliminate that pi. So then I have 64 equals r squared. So r becomes plus or minus 8. Now in geometry, we know distances aren't negative. So we're going to eliminate the negative 8, and we know that the radius then is 8. So now I have the radius. I can get my circumference formula and substitute that in. So the circumference is equal to 2 pi times 8, which is 16 pi. When you're working with circles, you can leave your answers in terms of pi. There's no need to multiply them by 3.14 or the pi key. Actually, leaving it in terms of pi is a much more accurate answer. Now, over here, I'm going to put that second problem that you have in your packet but isn't on my screen. And that is, now we are given the area, or we're asked to find the area. So that's what we want. We want to find the area. And we are given the circumference. And that circumference is 18 pi. So again, I write down those formulas. Area is equal to pi r squared. Circumference is equal to 2 pi r. What they have in common is that radius. So if I can find the radius by solving for the circumference formula, I can find the area. So in this case, the circumference is 18. So I'm going to put that in as the circumference. 18 pi is equal to 2 pi r. Now I'm solving for r, so I'll divide both sides by 2 pi. They cancel. The pi's cancel. 18 divided by 2 is 9. That gives me a radius of 9. And then I can substitute that in and find the area. The area is equal to pi times the radius squared. So my area is 81 pi units squared. Okay? And we'll practice more of those. You will see those on the chapter test, so it's good to know how to get from one to the other. We have a couple of postulates in this section. One is postulate 1-9, which says if two figures are congruent, then their areas are congruent. So if I had two polygons, A, B, C, D, and E, F, G, H. So if I knew that A, B, C, D was congruent to E, F, G, H, then I would know that their areas are equal. And I think the last postulate is 1-10. The area of a region is the sum of the areas of its non-overlapping parts. So what this means is if I have a polygon that is irregular in shape, then I'm going to just divide that. So let's say this is a 5. Let's say this is a 7. This is a 5. A 4, and perhaps a 1. If I want to find out the area of this shape, I can just divide it into 2 polygons, this one and this one. Find the area of each and add them together. So the area of the first one, which is just a rectangle, base times height, would be 7 times 5, which is 35. Then the second one, the area is again base times height. So I have 1 times 4, which is 4, gives me a total area of 39 units squared. Okay, I think that's the end of the notes. As I said, we'll do the packet problems in class. So if you finish the notes, you're finished with the homework. Have a nice weekend, and I'll see you Monday.